up today. Inshallah, we'll have a good session on sharing our senior design experiences. So in that, I am going to share my screen now. So if Sanatullah, if you could let me know if my screen is being shared or when it is, please.
Yes, we can see the screen. Please go.
Okay, let's go ahead and begin. Bismillahir Rahmanir Rahim. And here, I just wanted to give a quick overview of senior design in general. Okay, we've been away for the summer, no senior design in the summer, alhamdulillah, but now we're back into another semester. And so what I wanted to actually touch on first, just the basics. Okay, so all of us here are talking about engineering design. And what is it generally? If I can pull up my laser pointer here, it's a process. Okay, and I'm guilty of this definitely, and maybe some of everybody else is too, that a lot of times we focus a lot on what is the outcome of senior design. Okay, what are we getting out of it at the end? Here's this thing that I have. Okay, this thing in my hands, and I have a prototype, or I have this process, I have this piece of software. But in essence, senior design itself is actually a process, right? And that's not just my definition, okay? That's what's supposed to be coming out of it. And this is according to even ABET. So it's important to focus on, senior design is a process that's going to lead to an outcome. So if we follow that process, inshallah, we're going to get to something really good. And here is something directly lifted from the ABET manual for engineering, okay? And it's not very much different in some of the other ones, okay? But this is from the engineering section. Is engineering, okay, in quotes, right? Engineering design is a process. That's the beginning of the statement. And it's a designing of a process. Engineering design is a process for making some kind of product, whether it be, devising a system, component, there might be a process itself, manufacturing process, and it's going to have specifications and constraints. Furthermore, ABET itself states that all of our curricula, okay, I'm talking to the engineering folks here again, must culminate in a major engineering design experience that, number one, incorporates of the appropriate engineering standards and multiple constraints. So we got to keep that always in mind as well, that there's going to be some standards, okay, and every discipline is going to be a little bit different here. And so we got to keep that in mind, that maybe we need to go and look at the standards for our specific program, whatever that is. If it's going to be IEEE, maybe if we're an electrical engineer, or ASTM if we're material science, or ASME if it's mechanical engineering, etc. And so we need to be using those standards whenever possible. And there's always circumstances where we can use those, because especially ABET's going to be requiring these things. Actually, they do require these things. And we also need to make sure that the students are including in what they're doing multiple constraints. And that's usually pretty easy. And then the last obvious thing is, this is usually senior design, right? So the students have taken a lot of earlier coursework, and obviously we're supposed to be saying what they're doing is building on what they've done in their earlier coursework. But we're saying it's a process, okay? And there's more than one way to, do said process. And so I'm picking up on, after reading several books on this topic and teaching this many semesters, this is the way I'd break it down generally. And I think it's, very useful for most of the disciplines, if not all, but of course, everybody has their own take on everything. But, the main 4 steps to this process itself, I'd say, are the project definition. So this is the project itself, which leads then to defining a product, which then will lead to a conceptual design. Okay, and there's lots of stages going in between each one of these, of course, which eventually takes us to the product development. And for every semester or class, of course, the product development usually is the thing that takes the longest period of time. And then these first ones up here take less time. But if we've followed the process, then we're going to lead into a product at the end. And again, I'm trying to emphasize in this slide that we're not just worried about the product. Okay, so yes, that's maybe what the company, if we're working with company, or if we're a faculty member that's giving a research project, that may be what we're worried about. But for the students, what we're concerned about is teaching them this process so they can go out into the world and actually follow this process again to develop new things. Okay, so it's a process. We're teaching the design process here, and it will lead to a product, inshallah. Okay, so I said in my little brief intro about what I'm going to be talking about, okay, if you read that online, that I talk a little bit about my experience teaching senior design in the United States and the differences maybe between what's in the United States and here in Saudi Arabia. And so in the US, things are run like a business, okay? And I know I didn't say this up front, but if anybody has a question at any point, please, just go ahead and raise your hand from now, and we can answer questions at any point. And Sanat Allah, if you can remind me that somebody is there and needs help or something, just let me know. But put up your hand and inshallah, I'll answer questions at any point. In my mind, this is a panel discussion and I'm just giving information. And if you need clarifications or want to interject, by all means, please do. So in the United States, I taught for 13 years. And a lot of those semesters, I did teach senior design. And in the US, they run it like a business. Okay, this is the typical US mindset that what they're trying to do is to run it like a business, to use the engineers as doing real engineering work. Okay, I'm saying the senior students that are going to be engineers to do work, and they're going to run it like a business. And in a lot of universities, the projects are coming primarily from industry. So this happens in different ways. The individual faculty members that are assigned to maybe a section with so many students in it will go out, or a senior design coordinator is going to go out and seek projects at companies. And so they really just go out and physically meet or call people on the phone. And then over time, they develop contacts and they can go to these people and get projects. And in a lot of universities these days, because it's run like a business, right? Then the university is going to expect that the companies pay for the engineering work and this access to students. And so this is the way they look at it is now there's customers, which are the companies that want students and they want engineering work. And so they're going to expect some level of financial compensation for that. And so this is really the inner workings of everything. And it's not so glamorous and whatnot. It really is driven by money a lot. And so here to the right, I'm actually giving you some real, these are rock solid examples that I got real numbers from different universities and the numbers that they're posting. So at the University of Illinois and Georgia Tech here, these are like 2 top 10 type universities, some of the top universities in the world even. I talked to some of the coordinators there, and their senior design courses are actually 1 semester, and that's pretty standard in most universities. And they're getting, look here, I'm putting a specific word here, donation. Okay, so I said over here, pay, okay, but we have to be careful. In the US, universities are supposed to be not for profit. So they accept donations per project of 5,000 US dollars or 10,000 US dollars. These 2 universities are pretty big. And I got a rock solid number from a colleague there. And he said, every year they actually bring in about $250,000 US dollars. So 250,000 US dollars. And with that money, they're actually building a whole building specifically for design, senior design, and fully putting equipment in and et cetera. And Georgia Tech is a similar kind of story. They're even asking for more, and they have something pretty fancy. But even some of the lower ranked universities, you would say, are actually still charging a significant chunk of money in order for a student group to undertake projects. Okay, well, what's the benefit here of bringing in this money? Money is always nice, but where does it go? And so where does it go in the US? It goes into the department's pocket. Okay, so they literally generate revenue off of this money. And yeah, a lot of the money goes directly to the projects themselves, and then buying new equipment, materials, building facilities, like I mentioned, in order to make it even bigger. But there's always some leftover money that then the departments can use to do other things to enhance the departments, which usually makes the department chairman very happy. And then the students, what do they get out of doing these projects with the companies? Well, they get real world problems. Okay, these are real problems at these companies that maybe they can't quite get to, and they're like, oh, this is relatively cheap in order for us to just spend $5,000 or $3,500 to get an engineering solution to solve this thing. And then also the students, they actually can get jobs. And many times, okay, not every time, but I'd say easily 10%, if not maybe 20% of the time, the companies are then seeking one of the students on the teams to actually give them jobs to take that project and keep moving it through their company. So this is actually a real pipeline for the students, which makes them excited. And of course, the company likes this too, because they get access to the students for, and I put it last year, I guess, but recruitment. And then they're getting these real solutions to the problems. And what they're seeing is that they get 4 engineers. The students, for all intents and purposes, are 1 semester away from their bachelor's degree. So they're basically engineers that are being advised by a faculty member that has a PhD, making sure they're on track. And then they get all of these other little benefits from this. And the faculty, another thing that we get other than, of course, teaching and doing our job and having a job, I guess, are different interactions with companies. And I see that these things in the US actually lead to very industrially focused research projects as well. Okay, any questions on this and how it's run like a business in the US? Okay, no hands, I'll continue on. So, you go out and you can see, this is from a university that I was at from before, but there was actually, lots of different sponsors that we get. Some companies maybe you've heard of, maybe some you actually haven't, and you can get lots of different companies to sponsor things because they're trying to get access to the students. And a lot of people like to give back to their university as well. And so you find a lot of alumni are the ones that are giving the projects back to the university that they came from for various regions. And now I'm going to move on to an actual example of one of these. Okay, there's a company in New Mexico, which is in the southwestern United States, called Roman Fountain. So I'm just going to really give you, something that followed the process from students. I just copied and pasted out of the student slides. I didn't change anything. You can see these students, they're just candidates, right? But they're going to graduate at the end of the semester from their final presentation. I'm not going to give the whole thing. I'm just going to give a few of their slides. But this was about fountains, okay? And so you can see this is from the company's brochures and whatnot. You can imagine, in Saudi Arabia, we see lots of these fountains all around. And this company sells all over the world these kinds of water effects and whatnot. And they were having some problems with actually how the streams come out of, the water streams come out of the equipment that they had. And so they're saying we want a laminar flow nozzle, which means nice, pure stream, and it's not all broken up and turbulent, in order to dazzle our customers and for them to, give us more money. So the company objectives were to create a superior performance laminar flow fountain nozzle, unique water effects. So the students with the company defined this. And then they said, really what we're looking for as a flow effect, fiber optic lighting effect, high frequency water disruptions at 1 hertz. Okay, so they're actually giving some specifications here, but they're essentially communicating a need. Okay, and a lot of times what will happen is you not necessarily interfacing with engineers, you may be interfacing even with people that don't have an engineering background. And so you get some words like this, and then the students have this challenge of actually developing specifications, constraints of what was actually being said. And so the students did that, and you can see they came up with a laundry list of things. And then because it was so long, this company and the students sat down and said, what's the level 1 priority? Meaning you have to get all of these into your design. And then these other ones are a level 2 and a level 3. So you can sacrifice the lower numbers here for the upper ones. Okay, I'm not going to go through everything, but there's lots of details in here. And then the students come up with some kind of general scheme for actually undertaking the project. And then they use some different techniques. This is called the QFD, quality function deployment, something out of Japan from like the 1970s that they developed. And this is a way to rate all of the different technical requirements that are there against all of the requirements from the company itself and determining what's best. Okay, I'm not going to go through the details, but the students went through a very logical process to get them through their conceptual design review. But then they hit the midterm, and what they found was there's some real physical limitations. They had a heart-to-heart conversation, okay, a real conversation with the company saying, well, there's some things that are going to need to be adjusted, and we found some different challenges that we didn't expect in the beginning. And so with the company, they actually modified what they were going to do. And that's pretty normal, and that's okay. but it needs to be, determined, okay, and agreed upon by both sides if there's any changes. But the specifications, when you set them out, you got to make sure that, of course, the students are following them to the letter, and you got to hold them to account all of the way. But when things happen, then you need to be, accepting of this, of course, and things can actually change. But then the students, okay, after everything was done, they, made a little schematic. This is, a really cheesy one that was done, of course, in PowerPoint to start with. But, it's fun because you see this really bad sketch that they did in PowerPoint to kind of realize things that actually turned into a real design with real numbers and parts and everything, and their water source here. They're using the swimming pool at the university in order to do their project. And then they actually had to construct it. And then, they actually went in the machine shop and made things themselves. And, I think this is a really important part of doing design, is actually going and realizing you can make changes on the fly if you're the one actually in control of things. And we're going to talk about some things that I think we can do to get more towards that in the future. And this is for all disciplines. This isn't just mechanical. In the specifications, we lined out some of those. Again, I'm not going to dwell, but just the students are saying there's specifications, and then we did this and we met it and we did it and we kept these numbers all in line. Here's more fancy three-dimensional CAD drawings that were actually done, and then they manufactured the real part, and they actually were able to get, okay, really the things that they were asking for. They killed it. Actually, they were supposed to do 15 feet, but they did greater than 20 feet. But they noticed some things, they hit it, but there were some problems, and they learned a little bit more on that. And then at the end, they were able to actually start to modify their design just one more time, one more iteration, to make the company super happy. So they get a beautiful laminar flow coming through. And, they actually hit 8 foot and 12 foot with this very nice, with these very nice flow patterns and whatnot. Okay. And the company was very happy with this. It can go the specifications that had been said, but they had to modify things in a way that actually changed the heights and distances that they originally had gone for. But that made the company very happy with what they saw. And then they started adding in the other specifications that were requested, the other requirements, such as a light effect. So here's a couple of pictures. These are two separate pictures, put back to back, but they were able to integrate LED lights in there to actually make this really cool lighting of the flow. And you may have seen, something from this company, and maybe even these students, because this happened about, 8 years ago or something like that. But this is a good example of this. And I didn't put all the slides all the way to the end, but that's an idea of what's going on in the United States. And so there's some differences definitely that's going on there than here at KFUPM. Okay, it's about the students more than about businesses and making money. And it's a very personal kind of thing. And so we do things a little differently here. For those of you that are maybe newer and maybe not done senior design before, this is kind of an introduction. In the last year and a half, there was actually a task force that was put together for learning about senior design and what we've been doing up until now. And maybe is there some different ways that we can change things going forward. And projects typically have been coming from the faculty. Okay, and the faculty or senior design coordinator is typically designing the projects. Sometimes it's just things they come up with. Maybe it's related to something they're interested in or class, or maybe it's a research project, but there's not very much company involvement from outside, although there is some at times. Okay. And, that's a difference between what's happening in the US maybe and what's happening here right now. And then there's these other 4 pieces here. And so I'll introduce everything else from this perspective. Senior design itself, I think of it in 5 pieces. You have the project itself, like we just talked about. And then there's the course itself and what comes with that, and the students and faculty and resources. But all of these 5 things come together in order to make, of course, a successful project. And we talked about the projects, but the course itself in KFUPM, about half the departments have been doing it in 1 and 2 semesters, 1 semester or 2 semesters. And we're doing it in either 3 or 5 credit hours. So there's actually a range of the way that we deliver the course material to the students. And again, I'm talking about the university as a whole, not just one department. Okay, so yes, I'm from mechanical engineering, but I'm talking about as a whole. And the people that were on this committee that are giving this information, there's a representative from every one of your departments that are actually on that committee that fed into this, that are giving us all this information. students every semester. In case you didn't know, there's more than 400 students that are going through senior design and engineering at KFUPM. And the teams are typically made up of 3 to 5 students per team. 3 is usually on the low end. Okay, that's maybe a lot of work for students. 4 is usually the sweet spot, according to the faculty, that, that's a good range. But 5 is starting to get a little on the high end, because then, the students don't feel like there's something for everybody to do in some cases. And it's a little bit too big at times. And some students kind of, you say, fall between the cracks. They're not really, maybe they're able to disappear, not show up and do things. So usually, the 5-person teams aren't nearly as much. But that's a summary of comments made from the different people on this task force and observations over the years. Faculty, there's usually a coordinator from every department, and everybody's department, all 10 of us right now, there's going to prepare to be 13 departments in the very near future. And there's different levels of faculty involvement as well. Some departments just leave it on the coordinator, and other departments actually give a lot of assignments to the other faculty members as well. And that usually happens in the larger departments, is my observation. And then the resources, when we discuss the resources, there's limitations on the resources, and everybody has that kind of comment. We need to get more resources, things into the students' hands, and the timeline needs to be, a lot shorter. We need to get the stuff quickly to the students in order to make them successful. So these are the things that your coordinator in your department's made, the administration even aware of, and we've been delivering this to them and telling them that. And of course, these are things that you can, add additional information if you like as we go along. Okay. Now I want to move forward and say, okay, what I've talked about, what's been happening so far. I talked about the United States, talked about KFUPM kind of in general. And now I'm going to talk about, this new approach that, as a result of that task force and what was happening there, that the administration is saying, hey, we identified that there could be some changes to senior design, and we need some kind of, mandate. What are the things that maybe we could do better to prepare our students to be more successful in the new Saudi Arabian economy? And those things that were articulated are 4. The first one is student self-sufficiently. So the students need to be more self-sufficient in that they define their own projects, whereas typically we've been, giving students research projects, for example, or we come up with things ourselves to give the students. Now we need to try to give the students an opportunity to go out and actually define the projects themselves, go out to industry during their co-op, go out to industry during their summer internship, go out and talk to companies randomly. And we've actually started to implement this. And I can tell you the students are actually quite resourceful, and they actually amaze me quite a bit. And I think that there's some real things that they're capable of doing there that maybe we're not even thinking about. The next thing is the student-led inquiry. This is going to make them more self-sufficient as well. We want them to really go out and not be spoon-feeding them too much information. So that kind of language there kind of tells us inquiry-based learning. We want them to be leading the inquiry. We want them to be asking the questions and going out and discovering, and not having it necessarily coming from just us. And we want them to be creative and not just executing. Over the last 3.5 years, we've really shown them how to execute on different kinds of problems. But now we want them to be creative with the information and knowledge that we've given them, and to actually create new things and not just execute. And this is really what's going to drive, the economy, is when we get people into industry that are more creative and can, put all the pieces together and do self-learning and self-teaching and, leading their own inquiries into things. The next thing we mentioned here is that the faculty need to be advisors only. Okay, and so this one's a little bit different. Okay, maybe that doesn't quite make sense to start with, but we need to be there to just help and ask questions and guide them and not give them answers. And so we're being asked to, in this case, in this new approach to senior design, to actually really just leave it on the students and make them responsible. And, that could go bad. Okay. And so, it's been said before, I don't like saying the word failure. Sometimes students fail, but that's good. We want them to be in a safe environment of the university and maybe have these little failures, if you want to call them that, or challenges to try to overcome. And then us as faculty members, we should think about the grading approach. This is their last class. Okay, and so we're at the end of their career really, and we need to be taking a look at it more objectively about what's coming out of this. And what we're trying to do, and I tried to motivate this at the beginning, is we're actually evaluating their understanding of the design process. And that, if they do it correctly, should lead to outcomes and projects that are of high quality. But that's not what we're trying to do with senior design. We should be, in my opinion, trying to evaluate them doing the design process. Okay, and we want to have them come up with crazy ideas and take risks and be independent thinkers and creators. That's the kind of people that are really going to drive new changes in society. We don't want them to go out into industry and just be users of technology. We want them to be creators of new technology. And then the final thing is, out in industry, we're seeing more and more in the West as well as here in Saudi Arabia, that there's lots of multidisciplinary teams. It's not just a group of mechanical engineers now that are actually doing all of the work. It's actually going to be groups from many different disciplines that get together to do things. And business people are going to be on these groups sometimes too. And we need to try to avoid the siloed approach that we've been taking in the past. Okay, siloing meaning, I do my little chunk and then I move it on to the next person. We don't really talk. I just hand off what I'm supposed to do and there's no communication. We need a holistic approach to design. So this is a proposed new structure for senior design that may be coming to a department near you. Like I mentioned already, we've started a pilot program this semester with 5 departments, 3 complete departments and 2 departments that are having students voluntarily participate. Okay, and so some of these are clearly your departments as well. And so the way that the new structure going forward is envisioned to work is we split it into 2 pieces. Okay, senior year, senior design, that's what we've been talking about so far. And if we think of the inquiry-based learning type of nomenclature here, that's a level 4. What does that mean? It's open or true inquiry. The students find the project, find the questions, they answer them using the structure that they know from what we've given them as faculty members, and then come up with the result, okay, with the final product. And then in order to aid them going forward, we're going to see possibly some changes down at the lower level classes in the sophomore and junior year, where we're going to try to give them more projects where we introduce them to the design process itself. And we're going to enhance these classes, these core design classes, with the design process and those 4 pieces that I've showed you already. So this is kind of the thought process about how things can go forward. So we prepare the students better to go into senior design, because we identified as a task force, as a committee, that the students aren't necessarily ready on the first day to take on these design projects. Yeah, they have the classwork necessary for it, but maybe they don't understand design so well. And so this is the way to actually then make this happen, is to actually give them more background and opportunities in semesters prior to senior design in order to make it more seamless transition, let's say. So how would we do this? Okay, at the lower levels, just a quick thing. You can imagine or lecturing lots of things. We all do this, right? Course syllabus, lecture 1, 2, 3, all the way through 30 through the entire semester. We do lots of teaching, but we're trying to say here, maybe insert a little bit more doing into the class itself. And the classic civil engineering project is you get some popsicle sticks with some glue them together, and you can make a bridge. And then you can have competitions inside of the class where the students actually load up the bridge and see who wins, and you do a competition. And then you can do higher order things, maybe in later classes. If you're really talking about bridge design, you can think about the Warren type in the lower level, and they can do suspension and bridges in the higher level classes, etc. Or if we're doing something maybe in computer engineering controls, maybe even CS, you can imagine, giving the students all the pieces to actually make a robot, and then, okay, make it, put it together, and then you need to be able to demonstrate control of it using your phone, something like that. So do fun things in the class where you actually use the skills that you're giving them in the class, and then have them do IBL projects, okay, which is actually a form of IBL, which is project-based learning, or PBL. And so I'm saying, we're discussing this, and, this is starting to be implemented in some departments, that, with just 1 week of instruction, we do these kinds of things, and we have the students doing it in the sophomore year and junior year. And what's the goal? The goal is that we need to have the students initiating a senior design project where they come up with their own team company, idea, plan, and Gantt chart. And we need to tell them this throughout the entire process. And then that's going to prepare them for the senior year where they actually do level 4 IBL types of projects. So this is the envisioned outcome with this new type of program. Okay, this needs to come with resources. All of us, identified that there is this dearth of resources that, is on campus, and we need to do something different. And so we've actually done a lot of research and found some things we can model our new innovation center after. The administration's promised physical resources, okay, money, capital, equipment, materials, supplies, personnel, that kind of thing, to actually build up this facility. And we're actually looking to do this. And I'm going to go fast through these slides, but you can imagine, there's a computer lab, and there's going to be lots of machine shop stuff. Okay, this is actually at Carnegie Mellon that I recently, in the last couple of years, visited. And, this is envisioned to go at the KFUPM Mall or somewhere close, because this is where the students are at. Okay, and they need to be in a densely populated area of students. And this is why it's being planned to go over there. And this is in the, development phases right now. What's the benefit? Of course, the students can do multidisciplinary networking. Of course, they can fix their bicycle if they need to and go and use the equipment, but they can have meetings. They can actually go in and create and make things outside of class even, or for other classes. And it's a place for different people to come and meet, and even have other people from overseas come, YouTube makers that are actually, having 500,000, maybe 1 million types of subscribers to come and stimulate the students. And we've been in contact with some people to kind of bring them in and try to get people excited about doing design in the laboratory space. But overall, the Innovation Center is supposed to be a resource for all of the classes on campus to go in and do better, more efficient designs, inshallah. All right, this is something a little bit different. And so, I'm just throwing this up here. I'm almost done with this presentation, that, we need to be open to change. Immediately when we think of doing things in a new way, there's like, I don't want to do anything different. I might fail. There's might be some kind of harm to me. Okay, and this leads to negativity paralysis. So we put up barriers and we don't want to do it. Okay, but we need to, in ourselves, as well as the students, right? The students are right there, doing all of these things constantly, because senior design is something totally different than they've done from before. But we need to coach the students into the fact that change is good. Okay, you take your pick, right? Bill Gates. Okay, Bill Gates, Microsoft Office. Okay, I know a lot of people hate that, but Bill Gates actually did something different. And so that change was really good. And, he didn't, have all these successes right away. There was lots of failures along the way. Lots of things happened. I don't know. There's funny stories there, but I won't go into them now. And, same thing with Elon Musk. How many failures did each one of these people have before they got to something successful? Research shows that, these new type of entrepreneurs with all these risk-taking behaviors that they do, usually there's 9 failed businesses before one actually works. And that's okay. It's not about it being a failure. It's about what happens after you fail. Do you learn from it so you don't make the same mistake again? And we need to start that with the students now in the safe environment of KFUPM, and get them to the point of being excited about doing risk taking and having it in a safe, fun environment, and have them thrive off of it and be positive and feel empowered from it. And, talk about challenges and not obstacles. Okay. There's nothing that's impossible in this world. Okay, it's just a challenge. It's not an obstacle. Okay, obstacle is a negative connotation word, but challenge, okay, I can rise to meet the challenge. So we need to think of the words even we're using with the students and be positive with them. And let's be honest here, we're older than they are. And so, we probably have our own children. These are like our sons. Let's build them up and make them excited about things and make them want to make changes. Next thing here is, what's successful project-based learning? Okay, we have to acknowledge the students themselves when they go undertake their senior design projects. Our attitude is obvious. If we're using positive words, they're going to be reinforced in what they're doing, and they're going to be excited to come to class and want to do a better job to impress us and to do a good job for themselves. And if we are telling them this is going to help them with their future careers, this is going to be more beneficial. So we need to respect them and not condescend. We need to trust them and not mistrust them in different ways. And we've talked probably, some of us have talked face to face before. The cheating problem at KFUPM is there, but we need to trust that they're doing the right thing and not talk about these kinds of things. It's there in the background, but let's actually trust them. And if we trust them, then we are building them up to the point where they're going to want to really respect us and have us have a good opinion of them, and they wouldn't want to do those kinds of things. And then we need to engage them and not lecture. Okay, that's, lecturing constantly is passive. Do a little bit of lecture to give them a little bit of info on that day, but then engage them, talk to them. What are you doing on your project? Push them to be working harder and to go places and to question things and push. Then realize that students learn in lots of different ways. Okay, they learn visually, orally. Okay, they listen to things, or verbally, physically. Some people like to do projects and they're really good at it. So sometimes, students are really good at book work and they're not good at the physical. And some students are the other way. They're really good at physical, not the book work. And students maybe with lower GPAs in senior design, I've seen them do awesome and they get the highest grades and whatnot, but they achieve and they really realize that this was their true calling, was to actually go and actually make prototypes and design things and whatnot. So try to foster that in them and realize everybody learns differently. And somebody that's good at book work isn't necessarily good at putting together prototypes, for example. Some people are logical, social, solitary. They got to go off on their own. I'm going to go through all of these and describe them, but people learn in different ways. And so you need to be cognizant of that when you're working with groups. And you'll see that the students are responding differently to one another in groups, and you need to make sure that nobody's left behind. Okay, last thing here is we teach them in a lot of cases, okay, passively by just showing them lecture notes and slides and whatever, but we need to try to actively participate with them, showing them IBL. Okay, IBL, what is it? It's inquiry-based learning. We've talked about, we're trying to give them real world problems, and we want to give what they're doing some kind of meaning. Okay, I'm trying to move through more quickly now. And here's my favorite slide from the Deanship of Academic Development. They came up with this, mashallah, tabarakallah. It comes out of this paper from below, but there's 4 levels of IBL. The first one is confirmation, second is structured, third is guided, and the fourth one is open or free. Senior design is here. It's open, free. These students, we're not putting constraints on them from the beginning. Okay, they need to learn, push, whatever, and then they define their constraints, specifications based upon what they're understanding from the problem. Okay, but then in classes, we may be, giving them the question to answer, but not telling them methods or giving them the results. Or we could do more structured thing. Okay, here we go. This is going to be the lab for today. So these are more like lab classes here, where we give them the question, the methods, and what they should get at the end. Or we give them just the questions and methods, and we don't tell them what necessarily they're going to get. So what lab classes are kind of falling down here, whereas what we're trying to shoot for with senior design is more on this end, where the teacher, us, is having very low control, but the students are the ones really in control and coming up and being more creative. Last thing here is really the design process, and showing you that inquiry-based or project-based learning really falls under this. Okay, this is project definition, product definition, conceptual design, product development, which I showed you at the very beginning, and then using those definitions from before, the questions, methods, and results. This is the way to overlay IBL onto the design process. So using IBL, PBL, this is where you end up. You're asking questions more or less with the project or product definition. And then you're introducing methods in the conceptual design and the product development, which then leads to the results. Okay, so the results are over here. Yeah, we're going to end up with some kind of results. But what we're teaching in senior design is just this purpose, these 4 things over here. And level 1, we're giving them everything from beginning to end. But then when we move through the different levels, when we get to senior design, we're not giving them anything. Tell us what the project is, define that, and then start to do the product definition and move through the rest of the process until the end. Okay, so that's my quick introduction to the way things are moving with senior design, inshallah, moving forward with a proposed new method of doing things, and we're trying this out. And inshallah, maybe you'll see it in your department in the very near future. Last slide, just some things from the last, 16 years of teaching and looking at these classes. Okay, what are some lessons learned? Okay, I'd say there's 6 main points that I'd like to make here. Okay, we need to have the students be responsible for what they're doing. So a lot of times we're grading teams and we're missing the granularity of getting down to each individual student. So think about, ways that you can actually avoid having students getting a free ride and actually not doing things. Make sure you're paying attention in the classroom if you're working with them, and maybe develop an evaluation form. I actually have a peer evaluation form. I'm not going to show you now, but I have that I'm willing to share with anybody that talks about the different levels, and the students actually turn that in individually to me. And then I can actually rate the performance of the students based upon what we're seeing on that evaluation form. And that lowers grades. And there's actually multipliers for grades in the end, because there is an individual portion to doing these team projects. So as we're going through the semester, we should be asking questions and avoid giving answers. We just want to advise the students. I don't want to do the project for them. It's more work on me. It's more work on you. So why not try to advise them by just asking them questions? So we're actually putting it more on the students to come up with the solutions, because after this semester, that's it. They're by themselves. They have to come up with the answers on their own. Nobody's going to be helping them at their job when they're working in their cubicle. So why don't we give them that from now and try to help them with the right kinds of questions that be asked, and avoid giving them the answers, because that actually, actually breaks them down and makes them not able to deal with stressful situations where they don't necessarily know the answer. Another technique over the years that I've developed is to make the assignments in line with the project. So as they're going through the semester, they build the final presentation. So they're giving presentations periodically throughout the semester, but say, hey, these slides are going to go into your final presentation as well. That encourages them to do a better job and to not waste their time and take them off on, other tangents and whatnot, okay? Because this is a big class, there's a lot going on. And the final thing here is build the final report as well throughout the semester. Have them do installments of the final report as they go through the semester. So then at the end, they're not, struggling in the last week to write this huge document. Have installments of the final report be the assignments, and make it all in line with the project and the class itself. And in your grading rubric, whatever it is, and I think Dr. Sajed is going to be talking more about this and show and share some documents and whatnot, is that your rubric should contain the constraints and specifications. That's what, on some level they're being graded on. Okay, it's not just these two, of course, but make sure the constraints and specifications are there, and it's laid out from the beginning how you're going to actually grade them using your rubrics based upon constraints and specifications, and make the grading policy very clear. Next thing is stick to the design process and timeline. Have a process that you're following and tell them the timeline and stick to it. This teaches the students time management skills. Okay, students inevitably are always trying, trying to delay this and whatever. No, you need to tell them this is the timeline. If you don't turn it in, then there's going to be consequences. And we're just trying to help them with time management skills. And they're always trying to, push their luck and whatnot. It's just like our children, right? When they're not doing necessarily what they're supposed to be doing, they push you a little bit, but you need to put a firm hand down and say, no, this is the way that it's going to be. Finally, resources. Yes, we're trying to get more resources here at KFUPM, but we need to be the student's advocate, because this is a tough one, right? Because they're reliant on us to some degree and on the university to get what they need in order to do their job. So just be understanding and try to push things forward, inshallah. And that's all I had. Did anybody have any questions or anything? I've gone to my halfway point for this presentation. Okay, I don't see any hands, so hopefully, okay, there's one going up here. Yes, Usama, Sana Allah will send the link to the presentation, I believe, afterwards. Sana Allah, is that correct?
That's correct.
Inshallah. Okay. All right. If there's any other questions at the end, great, I'm available, and you guys can email me anytime and ask questions and we can talk more. Dr. Sajed, it's your turn.
Thank you very much, Dr. Zaid, for the presentation. And inshallah, I'll try to take it from your last slide and talk about some of our own experiences and share with our colleagues now. Is my slide visible?
Yes, it's clear.
Okay, thank you very much. So, Bismillah ar-Rahman ar-Rahim. I had an honor of working with Dr. Zaid in the last year and so for the university task force, and I learned a lot from him, and we had a lot of debates about different things he presented today. So I'll take an opportunity here to start from his last slide and share some of the experiences we have gained over the last maybe 10-15 years at our software engineering scene design projects. But before I go on and present, I'd like to acknowledge that the content I'm going to present today, specifically with reference to processes, templates, and rubrics, have been developed by my colleagues over the years, and I'm just here presenting on their behalf. So as part of my presentation today, I'll start off with specifically for software engineering projects, our logistics, and then I'm going to talk about the project phases and management styles we use to manage our scene design projects, specifically for, again, software engineering ones. Weekly deliverables, and I'll share a couple of samples, templates, and screenshots of grading rubrics. And later on, I'll talk about some success stories we have over the years, and eventually I'll talk about what are different improvement opportunities moving forward we believe are there, and some actions which need to be taken. And I think we saw some of those actions already taken and shared by Dr. Zaid earlier in the presentation. So our program, let me take my pointer, probably that's better. So our program, has a 5 credit hour senior design project. It's 2 courses. And I believe, if I'm not mistaken, probably we are the only ones in the university, specifically to engineering programs, who have 5 credit hours as senior design project. And we had this 5 credit hours senior design project for last many years. And during our different round of the continuous improvements and revision of the programs, we have stick to 5 credit hours, and there is a reason for that, because we believe that over the years it has worked very nicely for our students in order for them to apply all the different concepts they have learned throughout the program related to software engineering, programming, web development, and so on and so forth. And this gives them an amazing opportunity to go through the whole life cycle and develop their own products. Our teams consist of 5 to 6 students, and since it's a year-long project, so these teams, of course, they are together for the whole semester, for the whole year. And when it comes to the logistics of the teaching assignments or the faculty, usually a section contains about 35 or less than 35 students, which translates into 6 to 7 teams. An instructor can have 1 or more sections in a given semester, depending on the load. But at least there is 1 instructor which is responsible for each section. It varies. For example, this coming academic year, we have already 5 sections with about 35 students in each section. So that's translated about maybe 120, 130 students. And it has been, good news for us that over the years, again, this course has been counted towards our teaching load, which I know in some cases is not done. Just going back to history, and over the last 10 years or so, what are the different sources for these projects or ideas? About 95% of our projects are coming purely from students. In fact, over the last 10-15 years, we have been encouraging our students to come up with their own ideas, and bulk of 95, even more, to be honest, percentage of our projects are student ideas. They go on and share their ideas, and of course, through the whole process of senior design project, they improve those ideas, they enhance them, and eventually develop the product. We had few industrial sponsored projects as well over the years, and ranging from Aramco to some of the IT development companies here in Dammam and Riyadh, companies like Ramal IT and Ilm and so on and so forth. And very rarely we have seen a design project sponsored by a ICS faculty. We have kind of, an unwritten rule in a sense, or kind of an understanding in the department that senior design project instructors will not be sponsoring any projects. So in other words, if I'm an instructor for a given semester, I'll not be giving ideas to my students. And of course, the reasons are very obvious. We want to avoid any potential conflict of interest. At a given time, I, as an instructor, could be managing 6 to 7 teams. And of course, you would like to avoid all potential conflict of interest scenarios. And of course, more importantly, again, we want our students to have entrepreneurial abilities. We want them to go on and come up with their own ideas. And this is something Dr. Zaid was mentioning in his presentation as well. Now, typical assessment plans, since it's a teamwork, and of course, that's also a very, very important aspect of senior design projects. So 80% of the grading comes from the team submissions. However, as Dr. Zaid also said in his presentation, we want to also make sure that there are no free riders. And to help manage that aspect, we do a peer evaluation, and it has worked very nicely. And I was looking at the historic data, and actually really students give very clear feedback on their peers on different levels of contributions. I will not be sharing a screenshot of the peer evaluation form today, but if someone is interested, please feel free to contact me and I can share it. We also keep 5% with the instructor, and again, the reason is to make sure that, in a given scenario, because working with teams of 5 to 6 students, you're bound to have students with different backgrounds and different, potential conflicts can also happen between them. So we keep this as well. And of course, we have a weekly summary or weekly progress report, which is due by all individual team members. And it also helps us manage the project in such a way that we make sure each team member is contributing to the overall weekly submissions of the team. This is our typical process or phases, and this is in line with software engineering development life cycle. And I'm pretty sure if the names will be different, but probably the process will be similar for all other engineerings as well. We start off with project proposals, then we move on to its requirement phases, and we try to understand what are the different features this system they are developing should have them. We go on and focus on their architecture and design. And of course, this is very, very key part for any senior design project in an engineering domain. And later on, they go on and implement it, they test it, and they deploy it. So what we're trying to do in senior project is we're trying to let the students experience the whole development life cycle. And of course, they have already taken individual courses on these topics anyway. So we want them to now have an opportunity to go on and come up with their own ideas and then go through the whole development life cycle and come up with products. Now, at our department, we are usually doing or following this process in 2 main approaches. The very first one is the waterfall process approach. Some of us do it, and what we do is in the first 3 credit hours course, we focus on project ideas, their proposals, enhancement of them, coming up with complete requirements of them, and coming up with complete design and all different software design principles and techniques. We want them to apply. It's all focused in the first half of the senior design project. And moving on to the second half or the second course, they focus on implementation, testing, and deployment. Now, this is one approach which is used by some of us at the software engineering program. And then there is another approach which we have been using for the last maybe 6 to 7 years, which is more like agile-based approach. And I personally use this one as well, is that in the first semester, we focus on the project proposals, complete requirements and features of the system. However, then we encourage them to go and only design 30% of the product, go on and implement that 30%, test it, and deploy it. And in the next semester, we give them an opportunity to revise their requirements based on the experience they have in the first semester. And then, of course, it goes through what we call sprints, where we go on and design next 30%, implement, test, take the last or remaining part of the features, design and implement the whole system, test them, deploy them. Now, this is something I and few of my other colleagues also use. And the reason is, or why we moved from waterfall to agile, or some of us are doing it, is because another very important aspect of a senior design project is self-learning. And when our students come to senior design project, because of the dynamic nature of the technologies in our field, they are not necessarily aware of all the latest technologies. For example, mobile development. If they want to do mobile development, there's different frameworks, React Native, Flutter, so on and so forth. And this approach allows them to experiment with some of those techniques in the first semester, and of course, learn from it. And then when they come to the second semester, they are well prepared. They understand their weaknesses, their strengths, what worked for the team, what didn't work for the team, and eventually they come back and develop the whole system. And it kind of gives them an opportunity to continuously reassess themselves, self-learn, learn, and also understand, how to complete the project in a successful way. I'm not saying that which one approach is better than other, but this is something we have tried in the last 6 to 7 years, and I think it also has a lot of advantages when it comes to student learning and self-learning and success of the product. We also shared this this transition. Myself, Dr. Shaib, and Dr. Khalid, we wrote a paper in a conference as well to share this experience, that how we have moved on from waterfall model to agile model. Now, moving forward. We have, which is probably similar to all engineering senior design projects, is that we have a weekly submission. And it's a very well coordinated weekly submissions. Within each submission, we explicitly tell the students well in advance that what are the sections they're supposed to fill, and how they're supposed to submit these ones, and actually they build on each other, and eventually goes all the way to the prototypes and presentations. And this is a senior design first semester template, and similar one is there for the second one usually, with a focus on, depending on which process model you're using, the deliverables are accordingly. For example, these different templates we have developed over the years, they also highlight and indicate clearly to the students what are the expectations from them. Now, as I said earlier, we also want, in addition to weekly submissions or team-based submissions, we want individual students to also submit their weekly progress reports in a template, and which clearly indicates, based on their project schedules, what the tasks they were supposed to complete, what tasks were assigned to them by the team members, how much percentage they were able to complete. And of course, usually we ask the team leader to countersign that as well. And this has worked very nicely for us over the years, because it allows us to understand how individuals in a team are contributing, how they're contributing the team effort. And at the same time, if someone is struggling for many different reasons, it allows the teams to assess themselves and take necessary actions. This is a sample template. This is for requirements. And of course, we have developed over the years a template for different major milestones of the project. And we give this out to the students in the beginning. And for each subsection, we also have very clear guidelines prepared. Like, for example, 3.2, which is use case diagrams, and 3.3, we tell them what is expected in this according to their individual projects. And we give them clear guidelines about, what are the key things they should be submitting in this part of their submission. And when it comes to grading and feedback, which is also very, very important, because one submission builds on to other ones, and we have developed, again, for major milestones, rubrics to grade and give feedback to students. And we come up with different criteria, and within it, each submission or each part of the template, we give clear what you call indicators on what are the things which are expected and how much percentage of the weight it contributes to the overall submission. This has really helped us as a department, because since you're going to have multiple sections, it also kind of gives and streamlines the feedback mechanism, the grading mechanism, And in the beginning, students are also aware of what are the expectations from them. And as I said earlier, I'm just showing you one screenshot here, but we have developed different rubrics for major milestones, and probably they will be slightly different to different engineering disciplines. But if someone is interested, please feel free to let me know, and I'm happy to share that. Just to show some success stories, again, as Dr. Zed said, it's the process which is more important, and we are here to understand that the students make sure that they go through the design process and they experience different concepts they have learned throughout the degree. But at the end, we are also very much interested in making sure that we do have some products as well. And I believe, over the years, and probably because of the nature of the discipline as well, we have been very much successful in coming up with products. And this is probably an example that was done last semester or one before that. A team developed something called social health app. They were using, latest technologies like Firebase and Flutters, and it's a mobile application which runs both on Android and iOS. And of course, they explain their different, features and functionalities. Again, as I said, we have a number of teams over the years which are able to go and upload their products before the university expos on app stores or Google Plays. And this is something which is not gradable in a sense. It doesn't have any grade, but this is something we all encourage very, very strongly to our teams, that this is the aim we want them to target and to go on and achieve that. And a number of teams over the years have done it. For example, Team Plus, supervised by Dr. Scheib, they had their app available on App Store and Google Play well before the expo. We had over the years developed mobile applications, web e-commerce applications, video games. For example, I supervised this Nanoscott team, which was a Xbox video game, which was available on Xbox Marketplace for many, many years. It was sponsored by Ramal IT in Dammam. So coming to the last slide of my presentation, just to take and to the comment on some of the things Dr. Zed already presented in his presentation. We have been very successful, I believe, when it comes to helping students generate their own ideas. And something which we have been trying with probably smaller success at the moment is the industrial collaboration. We had sponsors from different organizations over the years, but then the percentage is very little. And I believe this is where, there's a lot of room for improvement. We have been trying to do that. It's a very difficult task, but this, I think, is very important, and it's in line with what is the new vision of the university when it comes to senior design projects. When it comes to involvement in multidisciplinary projects, specifically software engineering projects, we have not yet done that. And one of the obstacles is that we have 5 credit hours. Probably this is something we need to sit with our colleagues in different disciplines, in mechanical, electrical, controls, to understand that how it can be done. But I see there is a lot of opportunity here that our students can work in multidisciplinary projects with different engineering disciplines, and we can contribute to success of these multidisciplinary projects. And I'll conclude with one more last thing, which is the intellectual properties. Entrepreneur College, our school, has been very helpful for us, because over the years we have a number of teams who have come up with products, and they are very much interested in going on and marketing them. The college has been very helpful for us, but I think this is something at the university level we need to also think about it, come up with very clear guidelines about the IP property of these products, and this being developed as a result of these senior design projects. And I think this is very, very important. I think it will really help university move their senior design projects with a lot of industrial collaborations and multidisciplinary projects as well. And with this, I'll conclude my presentation. Once again, I'd like to thank Dad for giving me an opportunity to present today. And also, again, I'd like to acknowledge that the content I presented, specifically with reference to the processes, templates, and rubrics, is being developed by all of us at the software engineering faculty. And over the years, it's something we are very proud of. Thank you very much. So I'm available for any questions, please.
There is a message regarding the recording. Yes, it can be available, yes. Please go ahead, Dr. Adil.
Yes, Assalamu alaikum wa rahmatullah. Thank you very much for this wonderful presentation. Very good insight on some of the international practices and a good mapping between international practices and local practices. I don't have a question. However, I do have lots of some comments. I believe that the next step would be how to ensure the quality of the work that's happening. We've seen the best practices, but we haven't seen the steps for ensuring the quality and then applying it in at KFUPM. The information given here is very overwhelming. However, I would like to, I would like to start by myself, but I would like also to everybody else to think about how we can ensure the quality, how we can preserve this knowledge within the institution, the university, rather than just depending on individual people and individual efforts. It's a challenge, but something to think about. Thank you very much.
Any comments, Zaid, or?
Yeah, maybe
Yes.
Dr. Adil, maybe I can comment on that. You're absolutely right. And I think one way of doing it is to come up with these processes itself and coming with these templates, these kind of, well-documented best practices. And I think this way, it can be enhanced as well. And of course, it will be preserved for the colleagues to follow up and take it to the next level.
Okay,
Yes.
Zaid, you have to comment? Yeah.
Yes, Bismillah. Jazakallah khair for the comment. Yes, the steps for ensuring quality. This is a very important thing that we need to do and actually are trying to endeavor to do as we go forward in this experiment that we're doing. And, that really is only going to happen when all of the departments participate. And that's what we're having right now is we're having regular meetings and we're, going through everything with a fine-tooth comb, making sure that we're capturing everything, which is a large task. And so making sure, everything for ABET is actually going to be satisfied by trying to move forward with a new model, making sure that the quality standards are met for every department, as well as what ABET is requesting for each program and its specific, things that it needs to take care of, which are different program to program. So this is definitely a large effort. And, thank you for reminding us that we need to do that. And we're trying to do that. And inshallah, as the program goes forward, we need to have in place this continuous improvement mechanism by which we can actually ensure the quality. Totally agree. Jazakallah khair.
Dr. Samad?
Yeah, assalamu alaikum, everybody. My question is for Dr. Sajjad. You had presented one slide wherein you showed that the 95% of your projects in the software engineering program is from the students. What my question is, like, who ensures the level of that particular project, the scope of the project? Like, the students may come up with different kind of projects in their minds and all this kind of thing. Just to be fair with all the students, with all the teams, who ensures the quality of the project and who ensures the level or the scope of the project, so that the fairness is maintained between all the teams?
Yes, thank you very much for the question. Now, can you see my screen? I think I just shared it again.
Yeah, it is.
Yeah.
Yeah, okay. So I think it's an excellent question, to be honest. Now, what we do here is that as part of this whole process, this is the project proposal phase where we usually spend about 3 to 4 weeks. And the students come up with the raw ideas to begin with. Some of teams have excellent ideas anyway, but not all. So once they have raw ideas, I, as an instructor, for example, if I'm teaching this course as a coordinator, this is my responsibility to go and discuss with the teams. And usually we have a certain templates and criteria where we use to understand that, is this an acceptable scope, features which can be done by a team of 5 to 6 students over a once year work. So this is a very key part for us, and usually we take about 3 to 4 weeks here to really make sure and ensure the quality of the product, the concept itself, enhance it. And then if we are following the other process, then again, this continuously goes on in the second semester as well. When they come back and do the second semester, they have another opportunity to fine tune their ideas.
Okay, there's a
Okay, so,
question on the chat with Dr. Abdullah. How can we differentiate between undergraduate research and senior design projects? Should it be distinct always? Sajjad or Zaid, anyone can go for that?
I'll go ahead. This is Zaid.
Okay.
So how can we differentiate between undergraduate research and senior design project? Okay, this is a little bit different. So the distinction here really is about the process. I'll just go right back to that again. With senior design projects, we need to follow a rigorous process. MashaAllah, tabarakallah, as Dr. Sajjad actually just showed us, within his department, they're following one, and all the other departments as well, they're following some process that needs to be followed. The students go through it, they generate concepts, and then they evaluate them and they change them and so on and so forth. So it needs to be shown that it's a rigorous process that you're going through in order to, for example, make sure that you're hitting student outcome number 5 from ABET, which really needs to be satisfied in this class of all of them. It actually is called out in the regulations even. So that one needs to follow a rigorous process. But obviously, if you're doing undergraduate research, you use something a little different. And usually a faculty member has in mind something that they want, and it's at different stages. It may be, that you're not doing a design project from beginning to end. And if they are, then I guess there wouldn't be very much different. But a lot of cases, it's something that's already been established and the students are upgrading, using the equipment, doing a design of experiments rather than design of a product kind of thing. Okay, does it always need to be distinct? No, but for this, course that you're taking whatever number it is in your department, that one needs to be following a design process that then leads to something as a product or an outcome. So that's really the difference between the two. But obviously research projects can be geared to actually being something that follows the design process as well. Does that answer your question, Ihsanullah?
Okay, Sajjad, do you have to add anything?
I just second what Dr. Zaid said. The design component is very, very important when it comes to senior design project for an engineering program. And if the research has a very clear design product concept, then I think it can be done. But we have to be very careful when it comes to senior design project and research ideas.
Okay, great. Any more questions? Well,
Hi, may I
yeah,
ask
go
a
ahead.
question?
Yes, Tahir, go ahead. Yeah.
Yes, thank you so much. So thank you so much for a nice talk. I just want to know that as the model which Dr. Sajjad told us, that is a 2-semester model. How we can implement this model in 1 semester? How we can use these things in 1 semester? So any thought about it? If a department is doing this work in a single semester, how he can proceed?
Thank you very much, Dr. Tahir. I think the agile process I presented, it can be done within a semester as well. And what the department or the instructors have to do now is to understand that what are the different milestones they want to achieve, rather than one big go, rather than having these stepwise things, and at the end you have the product or whatever the thing you're developing. These agile processes can be applied within a semester. It could be a 1 weekly cycle, but something we call sprints, and it can easily be done. But for this to happen, probably the instructor or the department now have to go back and clearly restructure the process they are following for their senior design projects.
Thank you.
Okay, Dr. Zaid, you have to comment on that?
Yeah, sure. So one thing I would say, so with the new format and the pioneers, I guess, for this whole new pilot program thing, the way we've kind of adapted, I'm not talking about, of course, Dr. Sajed stuff. I'm talking about the way the new program is going forward. One of the things we identified was that on the front end, there's a lot of time that we spend developing the project definition. Okay, what are we going to do? What's the project going to be about? What are the needs, et cetera, et cetera. And that slows down the students a lot. And so on the front end there, what we've done is we've actually told the students the semester before, this is what you're doing, form your team, and then go out and find your idea. And then they need to submit their scope form before the beginning of the semester. And actually this last week, even the faculty that are doing this new format, we've actually been meeting and going through the 17 scope forms we received from those 17 teams. And so we're putting it on the students to actually go out and do these kinds of things ahead of time, to find it, go out, do the legwork, we would say, to do that. And then we review it, which speaks to the other point too, about, actually going through and ensuring the quality. That's when we ensure the quality up front, is we're making sure that we're screening the projects from the beginning, and there's a faculty member from every department that's actually on this committee going through, making sure that each discipline, each program's specific pieces are actually at the quality level that the department wants and at the quality level that ABET actually demands. So we're doing things ahead of time before the semester even begins. So the project definition portion is already done ahead of time. And then we jump right in and start doing the product definition, where we're actually defining how it's going to turn out physically, let's say.
Maybe Dr. Zaid, Tahir want to see what you're doing in mechanical engineering. Can it be done in 1 semester? And I remember this senior design project was 1 semester. And there might be, we will need to go back and see why they decided to take them to 2 semesters. So the question is, can it be done in 1 semester?
Yes, and that's the way we're doing it in 1 semester. Is a lot of the burden was actually on defining the project to begin with. And that was a lot of time that was wasted in the beginning, I would say. And so this is the way, one way we're working around that. And then we're streamlining some of the other processes as well.
May I add something, Dr. Zaid?
Please.
I'm just thinking of to send an email to my senior design project students. So we have a 1 semester, this system is, but the thing is the semester does not get started. How I can engage them in these things? And I don't know who will come in my team. I don't know their structures, who these students are, what type of courses they have taken, and how they align with me. These are the open questions for a faculty. Like if some students are coming from a different domain, they are coming to a new person who have a different domain, how they can work with him. So I think so. The 2 semester structure with Dr. Sajjad show us, that's really very easy for everyone. But 1 semester, I'm still very afraid of these things, what you have told, that we have to contact before the semester gets started.
Okay, I agree with you. That's, definitely something that we've been dealing with, going through, I'd say, the growing pains of trying to, figure out the good ways to implement this new way. It's happening in 1 semester. It happens in 1 semester in over half of the departments, actually, at the university right now. And your concerns are mirrored in several of the other faculty as well. We're working through it, and we have a good way, inshallah, to do this, but of course it's not been implemented across the university yet, and we need to work with this some more. There's going to be another semester of this pilot program coming up next spring, so then we can keep working out the kinks and making sure that everybody's comfortable with the new situation and that we've thought of everything, so we ensure the quality of the program, that's going forward.
Thank you.
Okay, any more questions? Well, if not, thank you, Dr. Tahir, thank you, Dave. Thank you all for attending. And please, you will receive evaluation for each one of these events. So please try to give us your valuable feedback, because this helps a lot in improving those events. Thank you. Thank you very much.